Good day to everyone. This video I'm going to discuss about the topic power electronics controller for brushless permanent magnet square wave motor. The third unit, the unit topic is permanent magnet brushless DC motor. So in this power controller of brushless permanent magnet DC motor, the power controller structure, it is this circuit diagram. So this consists of a power circuit, control circuit, commutation logic circuit, speed comparator, current comparator, monostable circuit, rotor position sensor, and then we are going to discuss about the functions of the entire power controller. So with respect to the power circuit of brushless permanent magnet square wave DC motor consists of 6 switches that are connected in the bridge configuration across the DC supply. A shunt resistor R is connected in series to get the current feedback of the signal. The feedback diodes are connected across the main devices. The stator armature winding it is assumed to be star connected, and the rotor carries the rotor position sensor, and the shaft is coupled with the tacho generator in order to obtain the speed feedback of the signal. And the control unit consists of commutation logic circuit, which gets information about the rotor position, and it decides about which devices have to be turned on and turned off. Next comes the commutation logic circuit. This logic circuit has 6 output signals, of which 3 signals are used as the base drive for the upper leg of devices. The other 3 output signals are logically ANDed with the high frequency PWMs, which are the output of the monostable circuit. So the resultant signals, these signals are used to drive the base of the lower leg devices. Next is the speed comparator. The speed comparator compares the reference speed omega reference with the actual speed which is sensed by this tacho generator. The output of the speed comparator, that is the error signal, it serves as the current reference for the current comparator. And now the current comparator circuit. So the current comparator compares the reference current with the actual current signal I actual, which is obtained from sensing the current using a current transducer, and the resulting error signal is fed to the monostable circuit. Now, with the discussion of the monostable circuit, it is excited by high frequency pulse signal. The duty cycle of the output of the monostable multivibrator circuit is controlled by this error signal. Now, the rotor position sensor RPS. The rotor position sensor converts the information of rotor shaft position into a suitable electrical signal. The signal from the rotor position sensor, it is fed to the commutation logic circuit, and in turns produces the output signals in order to switch on and switch off the various semiconductor devices of the electronic switching of the brushless permanent magnet motor. Now, the optical position sensor and all effect sensors are the most popularly used rotor position sensor for brushless permanent magnet motor. So the working of this power controller of brushless permanent magnet motor. So till now we have discussed the each devices and the circuits. Now we will discuss the function of the controller. So the position of the rotor is sensed by the all effect sensor, and these signals are decoded by the commutation logic circuit to provide the firing signals for the 120-degree conduction of each 3 phases. So it has 6 outputs. which is used to control the upper leg and lower leg of transistors. So the programmable logic arrays, gate arrays, EEPROMs are suitable for the function of this commutation logic circuit. So the PWM signal, it is applied only to the lower leg of transistors. So it is not, and thus this lower leg of transistor, these signals not only reduces the current ripples, it also avoids the need for wide bandwidth in level shifting the circuit that feeds the upper leg of transistors. So the upper leg of transistors need not be of the same time as that of the lower leg of transistors, and they are switched at commutation frequency. The use of this AND gates is a simple way of combining both the commutation logic signal and the chopping signal. So the monostable multivibrator circuit, it is excited by this high frequency signal and it is controlled by this error signal obtained from the comparator. The output of the monostable circuit and the signal from the commutation logic circuit, these two influences the conduction period and the duty cycle of the lower leg devices. Thus, we are able to obtain the desired speed according to the load requirement. So, this is with respect to the working operation of power controller of brushless DC motor. Thank you, everyone.